Okay, so I decided I think it's important for you to at least see an example of a small sample mean problem, which is this stuff from 8.4, and that uses the t-distribution. So I just wanted to run through one example of that, and we'll just do really basic problems from section 8.4. We will just do one-sided tests just to make sure you understand how to use the t-distribution and how to find an approximate p-value. So this is number 17 out of the text. It talks about pasteurized milk may not have a standardized plate count above 20,000 colony-forming bacteria per millimeter. The mean SPC, that's the standardized plate count, for 5 samples was 21,500 CFU per milliliter, with sample standard deviation 750 CFU per milliliter. We are supposed to test the null hypothesis that the mean SPC for this milk is 20,000 versus the alternative that it is greater than 20,000 at the 10% level of significance. And we get to assume the SPC follows a normal distribution. Okay, so everything starts out right exactly as other tests. So we have a null hypothesis and an alternative hypothesis. And if you remember, the thing they mentioned here was versus the alternative that it is greater than 20,000. So our alternative is greater than 20,000. So that means our null will be that it is 20,000. So those are our first two things. The second thing is checking conditions. Here in, I believe it says the mean for 5 samples was 21,000. So that means we have an n of 5. And it's a normal distributed. So these are the two conditions that tell you that you're going to use a t-distribution because of the fact that n is less than 30. And I do think you have to have this condition in order to be able to use this, and I think that's given pretty much in all these problems, is that you're normally distributed. I think that's important as part of the condition check. So these are the two conditions that you check to be able to use the t-distribution. So we know we're going to use t instead of z because we have a small sample instead of a large sample. So the next thing we do is calculate our t statistic, and it's very similar to the one for the z statistic. Actually, I think it's pretty much the same. So we just calculate all of this. So x bar was given in the problem. Let's see, the mean for the 5 samples was 21,500. And our mu naught is 20,000, so we subtract that, and then we divide by s, which they told us was 750 in the problem, and then the square root of 5. So you calculate all that out, I got a test statistic of 4.47. Okay, so that's the first 3 steps. Everything here looks really similar. The condition check is slightly different, and then the calculation of the t statistic is the same as the calculation of the z statistic. So now we're in step 4, right, which is to calculate your p-value. Here we're supposed to be testing at an alpha level of, they said 10%, so that's 0.1, right, that's your 10% level of significance. So if we kind of draw our picture, right, we have 0 here, right, and this is a greater than test, so we want this portion, right, to be 0.1. And so if you're thinking about your t-distribution, right, this is a t-distribution this time. Remember your degrees of freedom are important here, and that's 5 minus 1. Remember n minus 1 is 4. So if we go back to our t-distribution and you look at the table, right, so I'm just looking at degrees of freedom, right, this way is 4. And then I'm just looking at all these different values. And in this problem, we're interested in 0.1, right? T of 0.1. So if I look at T of 0.1 and I go down and look at that value for 4, I get 1.533, right? That's the number right here in our distribution. So from 1.533 to the right, you're going to have 10%. So 10% to the right of 1.533. And our number, right, that we got on that previous page, we got a t, right, that was 4.477, or 4.47, which is going to be way over here somewhere. So hopefully it's really clear, right? This is our rejection region, the stuff that I shaded, right? Anything above 1.533 is above our 10%. So it's really clear, hopefully, from the picture that we're certainly going to end up rejecting our null hypothesis because this is in the rejection region, which is the concept the book likes to use. But if we actually wanted to calculate or approximate a p-value, we can do that. And the way we do that is by looking at this table. So I'm going to actually make it a little bit larger over here and go through. So t of 0.1 we got was 1.533, and t of 0.05 we need, and t of 0.025, and t of 0.01, I'm going to run out of room, and t of 0.005. I think those are the ones we need. So anyways, I'm just going to kind of skip some numbers. You can look in the table if you want to follow along. But t of 0.01 is 3.747, and this one is 4.604 for 005. So right here, right, our number of 4.47 falls in between these two numbers. So what that tells me is that I can't get an exact value for my p-value, right? Like in the z table, I could just look it up. But we can't look it up here in this table, but what we can do is kind of get an approximation of that it's between these two numbers. So the biggest our p-value, it looks like, will be is 0.01. And it's certainly going to be bigger than 0.005. So it gives us a sense, right, of sort of the values that our p-value could take. It could go up to 0.01, but it's certainly and it's also going to be bigger than 0.005. So that's all we can do. We can't give a specific value for our p-value, but we can sort of get an approximation of where it might lie between. And we can also look at our picture up here and recognize that we're certainly going to, in our step 5, reject our h0 because this 4.47 is way into our rejection region. And another way to think about it is that our p-value is certainly going to be bigger or smaller than 0.1. So this is how we can approximate a p-value instead of just giving a specific one when we have a t-distribution and we can't calculate the exact. So the 5th step, right, we look at this and we get that our p-value is certainly going to be less than 0.10. We don't know exactly what it is, but it certainly is less than 0.10, so that means we are going to reject h0. And so in step 6, right, our conclusion here, I need to go back and look at the problem because I don't remember what exactly we were testing. We're testing that the amount of colony-forming bacteria in milk was greater than 20,000. So it looks like there is statistical evidence and you can say strong statistical evidence because it's pretty small if you want, right? There's pretty strong statistical evidence that this collection of milk exceeds the 20,000 CFU per milliliter allowed. All right, so whatever you want to say about the sort of conclusion, right? But the deal is that you now know, right, that this section of milk or the collection, the sample they took or wherever it was taken from, right, that whatever sample they took this from, that's probably not a good batch of milk. It has too much of this bacteria in it in order for it to be, I guess, drinkable. So that's your conclusion. And so I wanted you to just see a t-test so you can follow along and see that process of estimating a p-value. We did not get a specific p-value here, but you can still estimate it, and that's what I wanted you to see.